All right, this is the class for multiplying any two square roots and multiplying with square roots 2. All right, so we're going to start with an example, or more of a question. 4 times the square root of 4 times 9, is that equal to the square root of 4 times the square root of 9? So take a moment to do this carefully. I'm sure some of you can work it out. Pause it to work on it, or you can just keep watching and watch me do it. So what is 4 times 9? So we get 36. And then square root of 36 is 6. And on this side, square root of 4 is 2. Square root of 9 is 3. So we get 6. So they are in fact equal. We can say that they are equal. So now we're going to look at another example. Square root of 25 times the square root of 4. Okay. So what would we write on the right side? We would write 25 times 4. So just to see that the relationship holds true again, square root of 25 is 5, square root of 4 is 2, 5 times 2 is 10. 25 times 4 is 100, square root of 100 is 10. So we see that that works too. So, why does this help us? Why does this help us? What if they aren't perfect squares? So simplify. Square root of 32 times square root of 2. 32 is not a perfect square, and 2 is not perfect. So we can't take the square root of them easily without a calculator. Go away. But according to the pattern we just observed, we can turn it into a big radical and throw both of those under there, and it's still equal. Okay, so from here, 32 times 2 is 64. Square root of 64 is 8. All right, so we couldn't do it here. Could not start with square root. Could not start with square root because not perfect square. Okay? So it becomes a tool for us. So just to reinforce the idea that this is actually true, let's just look at a square briefly. So now each side of the square is going to equal this. Square root of 32 times 2. Square root of 32 times square root of 2. So the area is equal to square root of 32 times square root of 2 times square root of 32 times square root of 2. I'm running out of room, so I'm just going to bring it over here. And we're going to get square root of 32, square root of 32, square root of 2, square root of 2 by rearranging. And then that's just going to give us 32 times 2, because anything times itself with a radical over it twice is just that number. Square root of 32 times square root of 32 is 32. Square root of 2 times square root of 2 is 2. Okay, 32 times 2 is 64. So the area is 64. But when the area is 64, that means the side has to be 8. Because the square root of 64 is 8. Okay? Now, we have a few more tests to see. Square root of 64 plus square root of 36. Does it equal the square root of 64 plus 36? Okay? So we're going to get 8 plus 6, and that is 14. Okay? What is 64 plus 36? It's 100. Square root of 100 is 10. So they are not equal. Not equal. One more example, or a question. Square root of 9 plus square root of 4 equals square root of 9 plus 4. Are they equal? 3 plus 2, we get 5. 9 plus 4 is square root of 13. I can tell you right now that those aren't equal. Now, if I were to pose a subtraction version, will we suspect the same thing? Do we expect the same thing? Of course, they don't equal each other. Okay? So, what are the conclusions? What can we conclude from this? We can not separate or combine radicals with addition or subtraction. Okay? So we can only break things into bigger or smaller radicals with multiplication, and as we saw much earlier, division. Okay? So square root of 9 over the square root of 4 is equal to the square root of 9 over 4. Okay? Square root of 9 times the square root of 4 is equal to the square root of 9 times 4. Okay? So these are okay. Okay. These are not okay. These are not true. Yeah, you know what? Let's get rid of that okay. True. Not true. Okay? All right, at this point, you should be able to finish the handout.